And welcome in, my party people, to Distance Rate Time Part 2, where we're going to be taking a step backwards here. Because in the previous lesson, if you were here live, we're talking yesterday. In the previous lesson, we discussed distance rate time, where we have two objects, two runners, two people moving at the same exact time. Now, in this class today, very similar, except we're not going to be talking about two things moving at the same time, but one thing moving two separate times. And you'll see how the instinct that you have from yesterday's class, we're going to have to really manage that because we're going to learn more keywords, more situations to really wrap our heads around. So no matter what, even if you weren't here yesterday, we're good because the first thing we'll do is we're going to cover that distance rate time formula again. We're going to practice solving for each component like we did in yesterday's class. And then we're going to understand what to do in these new situations where we have one object moving two separate times and we have to understand the question that will be asked and how to solve it. So let's go ahead and just dive on in here. Let's remind ourselves of that formula. The distance rate time formula, everybody, is D equals R times T, where D is distance. And let me actually use a different color here, where D is distance, R is rate, and T is time. My party people pop quiz from yesterday's class. If we are solving for distance, what operation are we doing? Solving for distance, what operation are we doing? Is it addition, subtraction, multiplication, or division? Which one is it? If we're solving for distance. And if you said multiplication, that is correct. Because think about it. Read the formula here. Distance equals, so distance is the rate and the time multiplied together. So whenever we're trying to solve for the distance at the end, we can find individual distances by multiplying the respective rate and time together. And no worries, everybody. These are just, very casual exercises that I like to do. It sounds like a pop quiz, right? It sounds like I want you to, come to attention real quick. But that's because I want you to understand how to recall that memory as quickly as you can. Now, everybody, when we're working backwards, when we're trying to solve for the rate or the time, we got to get rid of that multiplication because we have to get rid of the other unit. So what is the opposite of multiplication? Absolutely. It's going to be division. It's going to be division. And so just remember this, and I'll give you a moment to write this down. Whenever you are solving for distance, you're multiplying the rate and time together. Whenever you're solving for either the rate or the time, notice that you're going to have the other thing in the way. So if I'm solving for time, I got to get rid of the rate. If I'm trying to solve for rate, I got to get rid of the time. And the opposite of multiplication, working backwards with solving equations, the opposite of multiplication is division. So whenever we want to solve for rate, we'll divide both sides by the time and do distance divided by time. You want to solve for time, divide by the rate. That way it's distance divided by rate and gives you the time by itself. So all in all, everybody, solving for distance, you multiply. Solving for the rate or the time, you will work backwards and divide. Yes or no in the chat box, does that make sense? Before we move forward. All right, my party people, so there we are. There is our fundamental distance rate time formula. Now, let's go ahead and just do a quick 2 exercises to just work forward and work backwards, and then we're diving straight into today's material. So here's a blank little page, and let's go ahead and discuss this little scenario. Let's go ahead and say we are looking at a problem where we want to find the distance. So we don't know what the distance is, but we are given the rate as, let's go ahead and say 17 miles per hour. And then the time is equal to, let's go ahead and say 8 hours. If I wanted to find the total distance that this vehicle travels, 17 miles per hour over 8 hours, what operation am I going to use, everybody? Pop quiz. Correct. We're going to multiply. Because remember, everybody, the formula goes distance equals rate times time. So with that said, everyone, let's go ahead and plug in the values that we have. Nice and simple. That's all you have to do. My rate here is 17, so I'll plug that in there. And my time is 8 hours. I'll plug that in right here. So once I do that, we have D equals 17 times 8, confirming that we will be multiplying. And then that's all we have to do now. 17 times 8, and we are done. Everyone, here we go. 7 multiplied by 8, that's going to give us 56. And we'll carry that 5. Once we have that 5 there, we're good to move forward. We'll have 1 multiplied by 8, which is 8. Add that 5 back in, giving us 13. So that's going to give us 136. Now, everybody, what unit should we be using here? Distance equals 136 what? Correct, miles. As a reminder from that previous lesson, remember that your rate is going to give away what your distance and time units are. This says miles per hour. So the distance is going to be in miles. The time is going to be in hours. So that's how you know what the units are going to be. In this case, it will be miles. And there we are. That's example number 1, my party people. Are we ready to move forward to example number 2? Sweet. Sounds good. Let's go ahead and tackle it. So example number 2, let's go ahead and say that we are given a distance of supposedly, let's say 196 miles, or let's go ahead and say 196 kilometers. Let's also say that the rate at which, or the time for which we travel, let's say the time is going to be, let's go ahead and say 7 hours. So with that said, everybody, if we want to find the rate at which we're traveling, what operation are we going to be using? Yeah, if we're looking for the rate, we're going to be dividing because we're working backwards. So let me go ahead and set that up for us so we can see it play out. So let's suppose we fill in the formula, distance equals rate times time, and we plug in the 196 for the distance right over here. Again, just plug in what you have to the right places. So 196 equals the unknown rate multiplied by the time, which is given to us here as 7 hours. So if you're looking at it like this, hopefully it's a lot clearer that, hey, how do I know I need to divide? Well, it's because if I'm trying to get the R, the rate by itself, that 7 is being multiplied. It's in the way. And we know that with equations, always remember this, it's about working backwards. The opposite of multiplying by 7 is going to be dividing by 7. And that's how we're going to get rid of the 7 on the right side because it cancels out. And now we just have to worry about this right here. So I'll zoom on in and I'll do the long division for 196 divided by 7. And we're good to go from there. So 7 going into 196. 7 goes into 19 twice. 2 times 7 is 14, so we'll subtract that right there. 19 minus 14, that's going to give us a leftover of 5. Drop that 6, and we ask ourselves how many times does 7 go into 56? And that'll be 8 times. 7 times 8 is 56, so we place our 8 right there. That's a clean division, and we are good. And so there we are. The answer here would be the rate is 28. Now, given the units that we used, everybody, kilometers and hours, what is the unit for the rate going to be? Ariane, instant. I love it. That was quick. Yes. Remember that your rate is always going to be distance over time. Kilometers per hour. That's going to be the unit for rate, and we are good. Kilometers per hour. And there we go. All set. All good. My party people, are we feeling the same way? Are we feeling like that was a good, quick little warm up on working forward and backwards with the distance, rate, time formula? Perfect. Perfect. So with that said, let's go ahead and dial it up here. Let's go straight to the first example that we have for today's practice. So here we are, my party people. And actually, before I show you this, here's what I really want to do. Let me go ahead and take this blank little note page that I created, and let me zoom in ever so slightly because I want you to write this. Consistency is key. Write this down for yourselves. So consistency is key. So essentially, if you want the time for the whole trip, well, you need to include the formula properly in the sense of, if I want the time for the whole trip, you need to use the distance for the whole trip and the rate for the whole trip. If you are trying to find the rate for the whole trip, you need the time for the whole trip and the distance for the whole trip. So let me write this down here. If you want distance for the whole trip, so for the entire trip, you need to plug in the entire time and the rate for the entire trip. You're not going to use the rate for the first part of the trip or the second part of the trip. You need the rate for the entire trip. Consistency is key. The way you plug things into a formula really matters. So everybody just write that down. It's going to take you, maybe 20 seconds to write that down with my bad handwriting, only because you have to squint. I get it. But go ahead and write that down. Consistency is key. So if you want the distance for the entire trip, you have to plug in the entire time and the entire rate. You have got to be consistent. I know it's easier said than done, but once I show you the first example, you'll know exactly what I mean. So type ready in the chat box and you're ready. I'll give it another 10-second buffer there, and we'll move on forward. Again, consistency is key. Make sure that you represent the formula consistently. And we'll talk more about that here in 3, 2, and 1. So, everyone, first things first, per usual. What's the first thing we do in a word problem? Exactly. No matter how confident or confused you are, first thing we're going to do is read that question. So it says, what is the driver's average rate for the entire trip? So with that said, everybody, can we confirm that what we are looking for is the rate, and not just the rate, but the rate for the entire trip? All right, so we have to be consistent. So if I'm writing my distance equals rate times time formula, this is all that means. I am looking for the entire trip's rate. So what you're going to need to plug in, you're going to need to plug in the total time, the entire time spent on this trip, and the entire distance driven on this trip. That's really it. The formula is there to be consistent, to be handled consistently. And as long as you commit to that, today's going to be easy. Everybody, which one are we going to plug in for the distance? Should we plug in the 40 miles or the 80 miles? Which one should we plug in? Yeah, exactly. It has to be both because context matters. Again, we want the distance for the entire trip. It says the driver travels 40 miles and then 80 miles. So we have to add these two values together because we want the entire trip. 40 miles is just the first part, 80 is the second part, but the entire trip would be these two added together. So we'll take those two values, 40 miles and 80 miles. Everybody, when we add those together, what's that going to give us? Correct, that'll be 120 miles. Nice and easy. Next up, everybody, we have that rate sitting there. That's what we're looking for. And what was the time taken for the entire trip? Yep, that's going to be 4 hours. Exactly. It's shown right over here. So we'll plug that in as well. R times 4 hours. Now, everybody, because we're looking for the rate, automatically, what operation are we thinking of doing? Correct. Now that we have the equation set up, we'll just divide and we're fine. So here we go. Divide both sides here by 4. Then we cancel out on the right side, and that's going to give us R equals what? Correct, 30. Now give me some units though. Don't be lazy. 30 what? Miles per hour, exactly. 30 mph. Booyah, there we go. And that is the average rate for the entirety of the trip. If we calculated the rate for this first part, we don't even know how many hours we took for just the first part, so we wouldn't even be able to calculate that if we wanted to. We would need more information. But we had enough information to calculate the entire trip's average rate. The answer here would be C. So with that said, everybody, does this seem simple enough for us to dive in and start immediately practicing with a timer? Great. Sounds good. Let's go ahead and check out the next one. I'll give you the time to try it out. If you're watching this as a recording, hey, feel free. Go ahead, set a timer for 2.5 minutes, and let's have ourselves some fun. Let's go ahead and get to it here. So let's get started on this second problem. And as always, we want to read the question first. So everybody, help me out here. Let's go ahead and read where it says, what is the cyclist's final distance from the starting point? Okay, cool. So everybody, what are we looking for here? Distance, rate, or time? Yeah, hopefully it's pretty straightforward here because we are clearly shown the word distance in that question sentence. So we are definitely looking for distance, but be very careful, because the one thing that I said yesterday, and it's going to ring true today, it's going to ring true the next session and the next session and the next one after that, is that we must make sure we understand the words, not just the numbers, but the words. So we want the distance from the starting point. So let's go ahead and create a starting point. Let's say we're going to make this right here our starting point. Let me actually make that a better, neater circle. There we go. There's my starting point. Now, with that, let's read the information here. What does it say? It says, hey, a cyclist rides 5 hours north at 12 miles per hour. Let me highlight that there in green. 5 hours north at 12 miles an hour. So I'm going to write down or draw a little arrow going up. Okay. So 5 hours, 12 miles per hour. And then it says he rides 3 hours south at 10 miles per hour. So what happened, everybody? After we go north, what direction should I draw my next arrow? What direction should I draw my next arrow? Down, exactly, to represent south. Exactly. So let's go ahead and use purple here. Let me highlight 3 hours south at 10 miles per hour. So after we reach this point here, we're going to come down, again, 3 hours, 10 miles per hour. So with that said, everyone, before we even think about, finding and calculating, what operation is it going to, what operation do you think we're going to have to do to find out how far we are from where we started? I see a lot of people saying addition, but the answer is actually going to be subtraction. It's actually going to be subtraction. And here's why. The reason that we're going to subtract is because, let's say whatever distance this is and whatever distance this is, let's say we have the numbers already. But the reason we're going to subtract is because we want to know, let me zoom on in here. We want to know how far away our person is, our cyclist is, from this spot here. We want to know this distance. That's what we want. We don't want the distance from here all the way here. And we certainly don't want to add this here and this here. We just want to know how far we are from where we start to where we end. And to do that, I hope we can notice that this part here, there's an overlap. There is a very clear overlap. Every step we go up and down, it cancels out. So all of this is canceled out or subtracted for the sake of getting us to where we end up. My party people, who here accidentally used the strategies from yesterday's class thinking that we're going to be automatically applying that in today's class? Yeah, and this is why I always say it's very important to treat every problem like it's a brand new problem. If you can fit the strategy that you used yesterday into the problem and you can justify it, absolutely. But if you can't justify it, don't make assumptions. We can always verify. So with that said, everybody, here's what we're going to do. Let's first find the distance going up here. Everybody, if we go for 5 hours at 12 miles per hour, what operation are we going to be doing here? Correct, we'll multiply because rate times time. 12 times 5, that's going to give us what, everybody? That's 60. Absolutely. Our distance here is 60. So let me highlight this. Our distance is 60. Now, let's go ahead and understand the coming backwards part. Let's go ahead and understand what happens as we travel south. Because it says we rode for 3 hours at 10 miles per hour. Everybody, what's that distance going to be? We're going to multiply 10 miles an hour times 10. And that's going to be 30. Exactly. That'll be 30 miles. Let me highlight that here and highlight this stick. Okay. So here's what we know, everyone. What we know is that our cyclist friend rode 60 miles north and then 30 miles south. So 60 plus 30 is most definitely 90 miles. That's arithmetically correct. But when it comes to the question, look at the question. Everybody, does the question ask us what the cyclist's total distance is? Is that what we're asked to do? Not quite. No, no, no. This does not say find the total distance. This says, what is the cyclist's final distance from the starting point? If we were doing total distance, we would take this and we would add it with this. That's not what we want. We want to know how far we are from here. How far are we from here to here? That's what we want. We want this distance there. And that's going to be 30 miles because this is 60 going up. We subtract 30 going down, going south. 60 minus 30 gives us 30 miles remaining. So it's 30 miles from the starting point, making the answer not B, but C. And again, the reason is because we are canceling out the overlap, canceling out what we erased from going north. So, for those of us that are a little frustrated for this first problem, were you able to notice, at the very least, why we subtracted before we move forward here? Yes, north and south are indeed opposite directions, and that's why we canceled out in this case. For those of us thinking that we should have subtracted, let me ask you this. Take a look at your notes from yesterday's class if you were here. And yeah, absolutely what you'll find is when you have two objects moving in opposite directions, we will add those rates and distances for sure. But everybody, huge exception here. Are we dealing with two objects? Or are we dealing with the same person traveling twice? Yeah, this is not the same situation. This is not the same case that we would use that logic in. Notice this is one person. We are not talking about two people moving at the same time, one north, one south. No, no, no. We are talking about one person moving twice. And this is subject to different rules, different context, different interpretation. Does that make a little more sense there, everybody? Sweet. Sounds good. I know it's tough, especially since we just did this previously, but that's why it's important to expose it to you quickly so you don't make assumptions like that. So let's go ahead and move forward here and try the next one out. What I'll do here is another timer, give you a chance to redeem yourself. Every problem today is going to be slightly different than the last. It's up to you to stay focused, read the question, interpret the information, make a plan, and try it out. And here we go. So the first things first, as always, we're going to read that question first so we can interpret the goal. That's what we want. So the question reads, what is the total distance traveled? Okay, everybody. What's different between this question, specifically what I'm highlighting, what is the total distance traveled, versus finding the distance relative to where you started? Yeah, this one's much different, right? We're looking for the total distance. So we are going to be amassing or accumulating or aggregating or adding all of the distances that we're dealing with. So that's the main difference, everybody. We're asking for the total distance traveled here. Let's read. It says, a cyclist rides at 15 miles an hour for 2 hours. Okay, sounds good. Let me just go ahead and say, hey, we do this, 15 miles an hour, 2 hours. And then at 10 miles an hour for 3 hours. Okay, I'm going to point it this way. And I'll say 10 miles an hour for 3 hours. It doesn't matter what direction I point this in. It could have been pointed this way. It could have been pointed this way. It could have been pointed up, to the right. It doesn't matter. Because when we're trying to find the total distance, all we care about really is from here to here, added with here to here. That's what total distance is. So let's put in the work and let's find each distance individually, add them together, and we are done. Everyone, what is 15 miles an hour multiplied by 2 hours? Because again, distance equals rate times time together. Correct. That's going to be 30 miles. That's going to be right there, our first distance. Now let's talk about our second distance. Everyone, help me out. 10 miles an hour multiplied by 3 hours over here is going to give us 30 miles. Exactly. So it looks like the cyclist went 30 miles and then 30 miles again. And because we're looking for the total distance, we are going to add these two distances together. 30 miles plus 30 miles gives us 60 total miles. My party people, does the difference between this question and the previous one, Does it make a lot more sense now? Right on. Right on. And so before I continue to the next one, remember everyone, the numbers here can change. It doesn't always have to be 15 and 2. It could be 15.2 times 4. It could be 27 times 18. So remember that the numbers don't matter as much as the situations do. That's the purpose that we're serving here in today's class. I want you to get used to the words around the numbers, and that's why you might see that we're using somewhat convenient numbers in today's practice. So once you continue in the practice on the website after the class ends, remember that those numbers, they're going to uptick a little bit. They're going to be slightly tougher, and I want you to be ready for that because as you practice, remember that word problems are 2 phases: translating the English into math and then actually doing the math. I want us to be comfortable with the translation part first. Got it, everybody? And are we ready for the next question? All right, next question here. Let's give it a shot. So the first thing that we're always going to do is read that question first. Let's see what's going on here. Let's see what the goal is first before we get confused. What is the total time taken for the trip? Everybody help me out. What is the key word or key phrase that we may want to highlight here? Yeah, both of those T words. Total time. Exactly. What is the total time taken for the trip? Okay, sounds good. So before we even continue, no matter how confused you were on this one, can we all agree that we are looking for the total time taken for this trip? Perfect. That's really all we need. Again, once we have this understanding, once we read the information that we're given, you'll see how doable this problem is. So here we go. Let's read the information that we're given. A race car drives 63 miles at 21 miles an hour and then drives 56 miles at 14 miles per hour. Clearly, this car isn't actually racing at this time, but you can see that we have 2 parts to this trip. We have 63 miles traveled at 21 miles an hour. Let me highlight that here in purple. So we have leg 1. Leg 1 says our distance was 63 miles and the rate was 21 miles per hour. Then for leg 2, let's highlight that in a different color here. Let's use blue. So for leg 2, we see that we drove 56 miles at 14 miles per hour. So leg 2 over here, distance is 56 miles, and then the rate was 14 miles per hour. All right, everybody. So now that we're here, remember that our goal is to find that total time. So in order to find that total time, everybody, do you think that it would be easier if we had the time for the first leg and the time for the second leg individually? Would that make it easier if we had those times? Oh yeah, for sure. I agree. Now, what would we do with those times to get the total time, everybody? If we had the time for each leg, yeah, we would add them together. Exactly. So let's go ahead and do that. Notice that the numbers aren't immediately there, but we can calculate them. We can absolutely calculate them. So let's zoom on in down here and let's do each leg. So leg 1, distance equals rate times time. So that's going to be 63 miles equals the rate, which is 21 miles an hour, multiplied by time. What number are we going to divide both sides by, everyone? Correct. We're dividing by 21. So let's go ahead and perform that here. Divide 21 on both sides. And that's going to cancel out on that right side, giving us 63 divided by 21 is 3 hours. So that's what we have for leg number 1. It's a 3-hour trip for the first leg. Now let's check out the second leg here. We have 56 and 14. So we'll have distance equals rate times time again. The distance was 56 miles, so just plug that in. The rate is 14. And then we're going to solve for that time. Everyone, again, what number are we dividing both sides by? Yeah, 14, exactly. So let's go ahead and divide there. Divide by 14 on both. Cancels out on the right side. And now we have 56 divided by 14. Everybody, if you don't know what that quite is, you're good. We can go ahead and do some simplification here because 56 and 14 are both divisible by 7. So if you didn't know that 56 is divisible by 14, totally fine. We can divide both sides, or the top and the bottom here, by 7 to start off. And once we do that, we'll see that we have 8 over 2. Everyone, what's 8 divided by 2? Yep, that'll end up being 4. Again, 56 divided by 7 is 8. 14 divided by 7 is 2. And then 8 divided by 2, that's going to give us 4. So we'll write that down here, our time being 4 hours. So everyone, think about it rationally. If that first part of the trip took 3 hours and the second part took 4 hours, the total time taken is exactly, it's going to be their sum, which is 3 plus 4, and that is 7. And there we go. Our correct answer here is 7 hours. So with that, even if we were confused before we did the solution, does this solution make a little more sense than it did before? Good. That's all we can ask for. That's all we can ask for, just making one little bit of progress at a time. So with that said, let's keep up the good work here. Let's try the next practice problem out. Here we go. First things first, read that question. So the question reads, what is the hiker's final distance from the starting point? So let's go ahead and highlight that right there. Again, pay attention to the wording here. We want the final distance from the starting point. So let's read the information and let's understand. So before I read the numbers, let me just read the words around them. So it says, a hiker walks east for this long at this pace, then turns around and walks west for this time and this pace. So ask yourself, everybody, if we are a hiker, here's where the hiker starts. If we are this hiker and we end up going east at first, and then we end up going west from that same spot that we ended up at, what are we going to do with those two distances? With this purple distance here and the blue distance here, what should we do so that we can find out specifically this point right there, the distance between these points right there? Correct. That's going to be subtraction. We want to subtract the overlap here so we can get the simple distance from the starting point. That's what we care about. So with that said, let's find those individual distances, subtract them, and get that final distance. Here we go. For the first part, traveling east, we see that our hiker over here, let me use purple. Let me grab that. East for 2 hours at 5 miles an hour. So we have the time being 2 hours, the rate being 5 miles an hour. Everybody, what do we do with a rate and time to get the distance? Correct. We're going to multiply. We are going to multiply. So 2 multiplied by 5, that's going to give us 10 miles. So this over here, from left to right, 10 miles. Next up, we'll go ahead and do the green. The green discusses walking west for 1 hour at 4 miles an hour. Okay, here we go. And let me actually change that to this right here and erase this over here so I don't confuse you with the other green. But now that we're there, we have our rate being 4 miles an hour for 1 hour. Everybody, if we're only traveling for 1 hour, what's that distance going to be? Yeah, that's going to be 4. Because remember my party people, that if it's 4 miles per hour, that means every hour it's 4 miles. Only 1 hour, only 4 miles. So there we are. We have 10 miles going east, 4 miles going west. We said that we would subtract to get that final point, and that's exactly what we'll do. 10 miles minus 4 miles is going to equal 6 miles. And there we go. That is the final distance that we achieve, or that we are, from the starting point, making B the correct final answer. There we are, my party people. How are we feeling about this next one? Do we feel like we're understanding the differences, the nuances between these different situations? Let's go. Right on, everybody. Right on. So let's continue the practice. We should be able to get plenty of practice in today's class. Let's keep up the great work here. Remember, fundamentals are important. Keep reading the question first, taking down the information second, and interpreting the information to make decisions. Don't make assumptions, make deductions. Here we go, everybody. Let's go ahead and keep up the good work. And here's the next one. let's go ahead and ask ourselves first, what is the question? What are we trying to find here? And so when it reads, we see that it says, what is the total time taken for the trip? So yeah, what we're looking at here is clearly it says total time. So what that means is there are potentially multiple parts to this trip. And so we need to find the time for the first part of the trip, the second part of the trip, the third part if there is a third part, and then we'll calmly add them all together. So here we go. First part, it says a driver travels. Right over here, let me catch the word. A driver travels 66 miles at 11 miles per hour. And then the second part of the trip here shows that we are traveling at 75 miles at 15 miles per hour. So 2 parts to the trip. We can find the time individually and then add them together. So again, it's just not one single step. It's a couple of different steps. So here we go. To find the distance for that first part, to find the time for the first part, we'll plug in the distance where it belongs, 66 miles. The rate we'll plug in at 11 miles an hour, multiplied by the time. Everybody, from there, when we set up the blue part, distance equals rate times time, so 75 miles equals the rate, which is 15 miles an hour, multiplied by time. Sweet. There we go. Now let's go ahead and find the times and add them together. So everybody, we are going to divide. So we'll divide both sides here by 11. 66 divided by 11 gives us what? That's going to give us 6. So we have 6 hours right there equals time. Now we're not done. We have to go ahead and find the time over here. So we'll divide both sides by 15 on the right side. And what we're going to get is, well, if it's not obvious, remember, when in doubt, simplify. Simplification works well. So when we take a look at 75 divided by 15, they are both divisible by 3. We can absolutely divide the top and the bottom by 3 to get this done in a slightly easier way. So 75 divided by 3 and 15 divided by 3. Everyone, what's 75 divided by 3? 75 divided by 3 is 25. That is correct. And then 15 divided by 3 is what? That is 5. So we have 25 divided by 5. Everybody, 25 divided by 5 is what? Yeah, that's 5. So hopefully for those of us that are still working on our mental math skills, we can definitely utilize simplification to make the calculation easier. So nonetheless, though, we have 5 hours for that second part of the trip. Everybody, what did we say? Are we going to add or subtract those time periods? Add them together. Exactly. So 5 plus 6, that's going to give us 11. And so therefore, the total time for this trip is going to be 11 hours. And there we are. Booyah. We can go ahead and highlight that correct answer nice and easy as 11 hours. And there we go. That is the next one knocked down. Nice and easy. Who here is feeling themselves? Who here feels like they're getting the routine going on here? They know what to look for and how to look for it. There we go. There we go. Now, me seeing this, I can only let you be happy for so long. I'm kidding. We're going to go ahead and try another slightly different type of question out. And, we'll see how it goes. But remember everybody, it is not about memorizing questions. It's about truly understanding them. We want to work to the point at which we can explain what we're doing with our words. Can we explain it through and through? Can we justify the steps that we take? Let's go ahead and try this next one out, and let's keep up the great work. Y'all are doing great. All right, now let's go ahead and take a look at this slightly different question here, everyone. Let's go. First things first, as always, we're going to read the question first. So, how long does the return trip take in hours? All right, everybody, can we tell me what the main word or main phrase that we should be highlighting here is? Yeah, we definitely want to highlight the how long, because how long tells us what? How long tells us how much time, right? Yeah, so we know that part. I think we are pretty good on that, but there's another phrase that we should definitely highlight. And yeah, y'all have said it already. It is the return trip specifically that we're talking about. Because everybody, if the question here was, how long does the trip to town B take? Well, what would that answer be? If we were just asking how long the trip to town B takes, That answer is obvious. It's on the screen. What is that number going to be? If we were looking for the time it takes just to get there, yeah, 2 hours. That's right there. A car travels from town A to B at 60 miles an hour for 2 hours. So that tells you the trip there. We want to find the trip back. So let's go ahead and make that distinction. Let's be clear about that so we don't confuse ourselves while we're taking notes. So again, the to trip, we see that it was at 60 miles per hour for 2 hours. So we have the rate, 60 miles per hour, and the time, which is 2 hours. Now let's go ahead and talk about the return trip. We want to know the time for the return trip. Let's highlight that here and see what we have. So let's discuss our return trip. What do we know about it? Well, we know that on the return trip, the car travels at 40 miles per hour. So we know that the rate is going to be 40 mph. And remind me, everybody, what are we trying to find for the return trip again? What are we trying to calculate? Correct. We're trying to find the time in hours. So let me write that down right there. Time is what we're looking for. Now, let me show you what can be very confusing about this problem, but what we should be doing because of this little observation that we're about to make. Let's zoom in and let's read. Everybody, specifically for the return trip, we have the rate. We're looking for the time. Everybody, what piece of information are we missing to be able to solve for the time? Specifically, as we look right here, we have the rate and we're looking for time. What's the other piece of information that we're missing here? Yeah, we're missing the distance. We are missing the distance. Let me write that down. If I had the distance, everybody, isn't it true that I could plug in the distance and the rate and then divide to get the time? Isn't that true? If I had the distance, right? But does the problem explicitly give us the distance? Is the distance explicitly stated anywhere? Nah, it's not. So that presents a little conundrum, just a slight inconvenience that we can absolutely get through. Because everybody, take a look at the problem, take a look at the information. Where can we actually find the distance on the return trip? Where can we find it? Yeah, on the way to the town. Because everybody, going to the town and then returning from that same town, we can make the assumption for this problem, we can make the assumption that they are the same distance. And that's the idea here. Because we have 60 miles an hour at 2 hours. Let's find that distance. Distance equals rate times time, so that's 60 times 2. What's that distance going to be, my friends? That's 120 hours. Exactly. 120 miles. Wow. 120 miles. And so with that, no worries, Anaya, I gotcha. So with that, we have what we need to solve this because I can take the distance being 120 miles and I can smack that right there because the distance to is the same as the distance back. So knowing that information, now we finally have what we need and we can put in the work and finish the job. So here we'll have distance equals rate times time again, the distance being 120, the rate being 40 miles an hour multiplied by that time period, and then let's finish things up. We'll divide both sides by 40 and we are done. Cancels out on the right side. 120 divided by 40 gives us what, my friends? Yeah, that's going to be 3. Specifically, 3 hours to get back. And there we are. There's our answer. The answer here is B. And if you want to think about it even more, this answer makes a lot of sense because, everybody, what happens to the time that it takes you to drive if you slow down from 60 miles an hour to 40 miles an hour? Is it going to take you more than 2 hours or less than 2 hours? Yeah, it's going to take you more time. If you go slower, it's going to take you more time. And this makes sense. We went slower and we found that it took more time. So just wanted to express that out there that you could have eliminated C and D knowing that we went slower for the same trip, for the same distance. So C and D could have been eliminated immediately and you probably could have gotten away with taking a guess between A and B. So with that, There's another one, my party people. Notice there are so many ways that we can twist these problems up. So just remember, no matter what, stay true to your basic strategy. Not just with distance, rate, time, but with every word problem that you do. Read the question first, understand the rules of the game. Once you know how to win, find the pieces you need to win. It's that simple in terms of saying it. I know in practice there's a million points of contention and frustration. I know. I've been there. I was a student before. But you have to have that mindset of looking forward to making mistakes so you can learn how to explain them better, and then looking at the problems that you get correct and doing the same exact thing. Practicing your explanation of the problems that you do, right or wrong. Everybody, are we ready for the next question? So here's yet another question, and let's give it our best shot. The first thing that we'll do is we'll read the question sentence. So I'm sure I've got this. Famous last words. All right, here we go. So what is the total distance traveled in miles? All right, everybody. So when we ask ourselves total distance, not the distance from where we start off, not any of that, but just straight up total distance. What do you believe we're going to be doing in this case? Yeah, if you think that if we have multiple distances that we should be adding those distances, then yeah, you're absolutely correct. Again, total distance means the distance across all of the events. So let's understand the individual events so we can then make decisions. Here we go. Number one, a driver makes a 2-leg trip. So everybody, when it comes to this context, a leg is just a part of the trip. So 2 legs means it's a 2-part trip. So we have 2 parts. Let me go ahead and list them out as part number 1 and part number 2. And one more time, everybody, we said we would do what with those 2 distances once we found them? Correct. We would add them, and that would give us the total distance. So you just want to keep that general idea in your head. Let's move forward here. So number 1, for the first leg, the driver travels at 50 miles an hour for 1.5 or 1.5 hours. Let's highlight that and write it down and keep it moving. 50 miles an hour, 1.5 hours. So we have the rate equals 50 miles an hour, and the time is 1.5. Regardless of if you like or hate decimals, that shouldn't matter. We know that to get the distance, we're going to multiply, so that's what we'll do. But before we do any math, let's keep gathering the information properly. We next see that we have a 1-hour break for lunch, and then beyond that, we later see that we continue the trip, and in that continuance, we have 70 miles an hour as the rate and 2 hours for the time. So let me write down that 1-hour break, and then I'm going to continue by writing down the 70 miles per hour for the rate, and the time is going to be 2 hours. So everybody, let's go ahead and put in that work. When I go ahead and see what we have going on, what am I supposed to do with that 1-hour break, everyone? Yeah, we don't do anything. We do nothing. And that's because when we are taking a 1-hour break, we're breaking from doing any work. We're not driving. We're not doing anything. It's just no distance. The distance is 0 during that break. So we can either ignore it or add 0, but either way, you're doing the same thing. So with that, let's go ahead. Yeah, we'll probably be eating. So with that, let's go ahead and find the individual distances for the first leg and the second leg and continue from there. Distance equals 50 times 1.5. Everybody, let's go ahead and use some mental math here. What is half of 50? Yeah, half of 50 is 25, everybody. Let me show you some mental math here. 50 times 1, that's 50. 50 times 0.5, or half, that's 25. So we have 50 for the 1, 25 for the half. What's 50 plus 25, everybody? 75. Look at that. Mental math right there. Boom. There you go. So that's 75 miles, and we're good. If you wanted to do the decimal multiplication, it would look somewhat like this, and we would do our thing, and we would still get 75. So I'm going to skip over that because we can use mental math for this one, and so we'll do that. Now, part 2 of the trip, let's keep it going here. We have 70 miles an hour times 2 hours. So 70 times 2, everyone, is going to give us what? Correct, 140 miles. So we have our 2 distances. And what did we already predetermine that we need to do? We already predetermined that we were going to add those distances together, exactly. And that's going to give us our total distance. So let's do that. Add these together. 75 plus 140, we can write that down over here. So 0 plus 5, that's going to give us 5. 4 plus 7 is 11, carry the 1. 1 plus 1 is 2. So there is our total distance is going to be 215 miles. And there we go. For the first time seeing a question of this type today. How do you think you did? How do you feel about this one specifically? There we go, everybody. So is it making more sense? Even if you're not getting them correct, right away, is the idea making more sense of, again, treating every question like it's a brand new problem so you can take it slow and understand everything first? Exactly. The phrase for that is critical thinking. It's all about critical thinking, everybody. We cannot make assumptions, but we must make deductions. That's what it's all about. Deduce what's going on. So let's move it over here to the next question here. We should have enough time for at least 2 more. Hopefully we can squeeze out a third, but we definitely have enough time for at least 2 more. Let's kick it going here. Let's have fun. First things first, as always, read that question, everybody. We can't get around it. That's the best thing we can do for ourselves. So the question reads, what must be the average speed in miles per hour during the second leg to cover the remaining distance? Okay, sounds good. So there can be some confusion here, everybody, because you might be prone to reading remaining distance, ? And think that we're trying to find a distance. However, everybody, are we trying to find distance here? Correct, we are not. We are trying to find the average speed. So let me, unhighlight all of that. Average speed is what we're looking for. But specifically, everybody, average speed for what? Correct, average speed for the second leg, during the second leg. So notice how this problem is getting even more complicated than the ones that preceded it. But as long as we focus on reading the question first, we're good. We're good. So here we are. We want to know not the first leg, but the second leg, and we want to know its rate. Is that true, everybody? Can we confirm that? The second leg, the rate for the second leg is specifically what we want. Good. Now let's do ourselves a favor and calmly collect the information so we can make some decisions. So here's what we start off on. First sentence, a driver embarks on a 2-leg trip covering a total of 280 miles. Okay, let me go ahead and write that down. That's going to be important information. I already know. So let me write that down over here. The total, and I'm going to say the total distance is 280 miles. Okay, sounds good. Let's keep it reading here. Let's keep it going. On the first leg, the vehicle travels at 50 miles an hour for 2 hours. Okay, so let me highlight that nice and easy. Let me grab blue. So the first leg, which is the one right over here, we see it's 50 miles an hour for 2 hours. So the rate, 50 miles an hour. The time, 2 hours. And before you calculate, remember everybody, before you calculate, we don't want to make assumptions. We want to make deductions. So let's read the rest of the information. Let's take it all down. All right. Next up, it says, on the second leg, the journey lasts for 2 hours. Okay, great. So we know that the time for the second leg is 2 hours. All right, so here we are, everybody. We now have everything. Let's ask ourselves, what are we focusing on? The first leg, the second leg, or the total? Where's our focus, everybody? Yeah, our focus, and I know there's a little bit of debate in the chat box, but our focus is the second leg. Remember, it always comes down to the question sentence. What we care about is the speed, which is the rate, for the second leg. So this is truly what I care about. That's what I'm going to hone in on. Now, everybody, check me out. Look at what I'm doing here. I only care about the rate for the second leg. Now, remember how we talked about the consistency that's needed behind the formulas. Remember, we got to be consistent. So if I'm focusing on this formula, while I'm looking for the rate, I do have the time. What do I need to be able to solve for the rate? What extra piece of information here am I missing to get that rate by itself? Correct, the distance. The distance. I need the distance for the second leg, which I do not have. I don't know what this is. However, everybody, is there a way for us to use the information that we were given, like the total between the legs, like the first leg? Is it possible to use that information to get that distance for the second leg? Absolutely. Notice that it's not as easy as just plugging one number in and being done. It's about understanding what you have and what you need. So let's figure out what this distance is, because then we can plug our numbers in and be done. How do we find that? Well, check it out. We know the total distance is 280 miles. If we knew the first distance, we could subtract it from the total and just get the second leg. Everybody, can we get the distance from the first leg with these pieces of information? We absolutely can. We absolutely can. So that formula, as always, is multiplication to get the distance. Distance equals rate times time. The rate is 50. The time is 2. 50 times 2, everybody, is 100. So we have 100 miles right there from the get-go. So, help me out. If we know that our first leg's distance is 100 miles, the total distance is 280 miles, what operation did we say we would do? Subtraction all the way, exactly. And so let's go ahead and subtract. 280 minus 100, that's going to give us 180. 180 for the second leg. So this is leg number 2's distance. So I'll plug that in right there, 180 miles. Now, everybody, do we have enough information to find the rate for the second leg specifically? Yeah, now we do, right? Now we do. So we're all set. We'll go ahead and write our formula out. Distance equals rate times time. Plug in what we have, 180 for the distance. Rate stays where it is, 2 hours for the time. What do we do to both sides? Kevin, exactly, we will divide. Great job there. So we're going to go ahead and divide both sides by 2. Cancels out on that right side, giving us the rate by itself as 90 miles per hour. And there we go. Notice how we had to take multiple steps, but everybody, with practice, can you see yourself getting this done in 2.5 or 2 minutes with practice? And that's the point. There we go. You can absolutely get it done in that time frame. We just have to work on repeating the repetition behind the fundamental strategies. Read the question first, read the information, set up your plan. I call it destination plan follow, or what do you want, what do you have, what's the connection? But there you go. So with that said, everybody, are we ready to try one more question out? Right on. Let's go ahead and give it a shot here. All right, so let's tackle this question here. I think this one is a very good problem to leave off on because it takes, again, some thinking, because in terms of the session that we're doing right now, we haven't done this yet. So let's give it our best shot. So first things first, no matter what, our goal is to read the question first. So here we go. Let me grab my highlighter and let's interpret the question correctly. If the overall average speed for the entire journey is 250 miles, again, extra information. This is information that we can use, not use, I don't know yet. I want to read the actual question. It says, what is the distance flown during the second leg in miles? Okay, sounds good. That's what I want to highlight, everybody. What is the distance flown during the second leg? Everybody, does it make sense that we are going to have the first leg, second leg, and then a total? But all we want is the distance for leg number 2. Does that make sense before I start taking down all of the information? Cool. Sounds good. Again, remember, that's the best thing you can do for yourself. You don't want to try to walk straight into a hurricane or a natural disaster. You want to brief yourself first. So boom, we want the distance for the second leg specifically. I've got that in my head. And now let's go into the information. So first sentence, an airplane flies, right over here. An airplane flies from city X to city Y at 300 miles per hour, covering 900 miles. On the second leg, It flies for 2 hours. So let's write these pieces of information down. So over here for leg number 1, from city to city Y, this is the first leg. Our rate is 300 miles per hour. And then our distance covered right over here is 900 miles. D equals 900. All right. So before we even continue, my party people, before we even continue, do you see that for this first leg, we have what we need to find the time if we needed the time? Do we see that we have enough information to find the time if we needed to? Okay, sounds good. So just keep that in mind, just in case we need to circle back and actually do that, we'll keep that in mind. Let's keep reading here. On the second leg, it flies for 2 hours. That's all the information we have for the second leg. For the second leg, 2 hours is the trip. That's all we're given in that sentence. So let me write that down. T equals 2 hours. That's not the first leg. That's the second leg. Then we're given in the next sentence that the overall average speed for the entire journey is 250 miles. Okay, sounds good. So here we go. The total rate or the overall rate for the trip is 250 miles per hour. All right, everybody, we have now written everything down. What we are looking for is the distance for the second leg. We have the time for the second leg, but we don't have the rate. So here's what we can do. We can do our best to try to, use all this information to try to find that rate, because then we can get the distance nice and easy. But there is a second option, everybody. And that second option is going to be derived from, guess what? If we want to find the distance for leg 2, everybody, if we had the total distance and the distance for the first leg, what would we do with those two pieces of information to get the second leg's distance? Oh yeah, we would subtract. If I knew what the total distance was, I could just subtract from it the first distance and I'd get the second leg. So take a look here. We have two big options. We have two options to go with, and that second option that I just stated is the right way to go. Watch this. Here's what we're going to do, everyone. If we have the rate and the distance, we can find the time. Let me show you what's going to happen if we do that. Let me find the time for us here. Distance equals rate times time. So we have 900 miles equals 300 miles per hour times time. I'll divide both sides here by 300. And what is that going to give us, everybody? 900 divided by 300 gives us what? Correct. 3 hours. So it's going to cancel out on the right side. And the time that we have here is 3 hours. Awesome. Everybody, why does that help us out? Well, guess what, everyone? Guess what? If I'm trying to find that total distance, well, if I have the rate and I'm trying to find the distance, what's the other piece of information that I need, everyone? If I have the rate and I'm looking for the distance, I need that total time. Remember, everybody, this represents the total. What's the total time that we spent on this trip? What are we going to do with these two times? To get that total time, we're going to add. We're going to add those times together, and that's going to give us 2 plus 3, and that's going to give us 5 total hours. So, again, what can we do with this? What can we do? Well, remember that distance equals rate times time. So I can find the total distance. The distance is going to be 250 miles per hour times 5 hours. Everybody, what is 250 multiplied by 5? You can just do 25 times 5 and put a 0 at the end. That's going to give us 1,250. Right there, 1250. Booyah. So with that, everybody, guess what? We're done. Because if we have the total distance, and that's 1,250, and we subtract leg 1, which is going to be 900 miles right there. That's the distance for leg 1. And we subtract, what are we going to get, everybody? What's 1250 minus 900? Yes, that's going to be 350. Let me zoom in and do it with us. 0 minus 0, 5 minus 0, 12 minus 9, that is 3. And this is leg 2. Leg 2 is 350 miles. And boom, it seemed like a super complicated problem, but you just had to do one extra step on top of that beginning step, and we would have gotten A as the correct final answer. And there we are, my party people. It wasn't that painful. I'll agree. Might have felt like torture. You're allowed to say it. But I hope you see that at the end of the day, regardless of how difficult something seems in the beginning, if we give it some time, some patience, and grace, we can get there through and through. So with that said, everybody, I'm proud of y'all today, and I'm really looking forward to the next one. How do we feel?